Hello and welcome to this discussion on fluid mechanics. So, in previous discussion, we have discussed um, about the governing equation for the fluid statics. Okay, and that equation came to be dp. Sorry, that that equation came to be okay. So that equation came to be dp dz equals to minus rho g, right? Okay, so this was the governing equation. So another thing is there that we have told that in any point inside a fluid containing container we have a particular pressure due to the existence of fluid, and due to that pressure there there will be some force if I put any body in that point. Okay, so now let us consider a very important topic, that is pressure force. Okay, pressure force on on flat or plane surfaces submerged in static fluid, because if the fluid is moving then there are another forces that may take place that we will learn uh, during during studying fluid dynamics. Okay, so let me draw a simple schematic quickly. Okay, let me draw a simple schematic, and that is, so here I have a tank. Okay, I don't have a tank actually. Let us say that yes, I have a tank, but that is not closed. Okay, so that is not closed. Okay, so this is the free surface. Okay, so this is the free surface. Fine. So then inside this tank I have, let us say, a plate. Okay, I have a plate oriented like this. I have a plate oriented like this. Okay, so this is the side view, or let us say that this is the front view. Okay, so but so if I view from this side, then it will appear something like this. It will appear something like this. Okay, so this is the side view, and from the top also, from the top also, if I project, then this will appear like also a square. So this is a rectangular plate, and it is put into the fluid, and in this case particularly this fluid is nothing but water. So this plate is having an inclination, okay, of let us say theta. Okay, and let us assume that the side length of the square plate, or let us say the side length of the rectangular plate. Okay, so if I draw the actual dimension, and that will come from this view only. Okay, so if I draw the actual dimension, sorry, okay, so then um, okay, so I have to draw, I think, by hand, because inclined rectangle is not possible here. Okay, so this actually, a good drawing motivates us, or helps us to study better. Okay, so let us say that this length, okay, that this length is, okay, this length is L, and this length, or this is the breadth, is B. Fine, this is B. Okay, so the dimensions are clear, right? And okay, we are also given, okay, we are not given, so we are given is the coordinates. Okay, that at least we are given the coordinates, that is, this is the coordinate system, this is the z direction, and this is the x direction, and perpendicular to that we have the y direction. So fine. Okay, okay, so now the thing is, we have to find the pressure force on the flat plate, named AB, named AB. So pressure force on plate AB. Okay, so we will apply this governing equation. So firstly, let us consider a strip. Okay, let us consider a strip here. Okay, so this is the strip, and this is having the length of dx, and on the surface, this is an area strip, or two-dimensional strip, shown by these two parallel lines, this and this. Okay, so this is having the length. Okay, so this is having the length of, okay, so this is having the length of dx. Okay, then the elemental area of this strip is nothing but, dA equals to b into dx. Okay, so this is dx, and this whole length, let us name it as CD. So this CD is b, and CD EF, so CF equals to DE equal to dx. So I have this dA. Now this is an elemental strip. Okay, so dx is so small, that this height variation here, this height variation, or uh, this horizontal distance variation, can be neglected. So at this point, so so dx is as good as a point. So at this point, let us say P, or not P actually, let us say K. Okay, let us say K. So at K, the pressure at K, what is the, pressure? Okay, so the pressure now is Here I have air, okay, above the water level I have air. So here is atmospheric pressure P atm, and that will directly impose on the water. And due to the hydrostatic law, from the free surface, the height is nothing but, from the free surface the height is nothing but this height of, or the depth of this point K. So let us term this as, Z. Okay, Z. Fine. So then we have this governing equation, dp dz equals to minus rho g. Okay. So then if I have to find the pressure at P, so then, sorry, the pressure at K, so then it will be P atm, and this will be the pressure P at K equals to minus rho gz after integrating, and this will be actually minus z, because in the bottom side the z is negative. Okay, uh, okay, in the bottom side the z is actually the coordinate system that I have taken. Okay, so in that case the governing equation should be this plus rho g. Okay, because in the actual, during the actual derivation I took the z in this direction, in upwards direction, but as I have changed the direction of z, so this will be plus rho g. Okay, and this is also plus z. Okay, so now the limit will be from 0 to z, because this level is z equal to 0. Fine. Okay, so then P of k equals to P atm plus rho gz. Okay, so we have found out the P of k, and this this parameter is called the gauge pressure. Okay, the gauge pressure, that is the pressure relative to the atmospheric pressure, gauge pressure at point K, and that is equals to rho gz. Okay, so uh, let us work with the gauge pressure pkg. Okay, so let me write it as capital G, because we have this small g here. Okay, okay, now I have found out this pressure, and I always have told that the direction of pressure at any point on a surface is perpendicular to the surface. Okay, is perpendicular to the surface, and it is compressive in nature. So this is a d of pressure force Fp. Okay, that is acting in this point. Fine. So if I have to find this d of pressure force, then what I have to do is, this d of pressure force is equal to pressure at k, and I am just working with the gauge pressure at k. Okay, so okay, let us work with the actual pressure and not the gauge pressure. I will tell you that why. Okay, so pressure at k into just d of a. So pressure at k is p atm plus rho gz, right, into this dA means dx into b, that is width, right. So this is the elemental pressure force. So the total pressure force is I have to integrate this. Okay, okay. Now, now this is dx. This length is dx. If I maximize it or zoom in it, so this length is dx. Which length? So let me put it in this color. Okay, so this length is dx. So then if I draw a triangle and I exaggerate this triangle here, then I have this. This is dx. Okay, this is dx. So actually I should not take this as dx because this may lead to a confusion because this is x direction, but okay, just for the time being assume that this x and this is x direction don't have they don't have any relation. Okay, so this is dz and this is in this direction I have this. Okay, so let us take it as dl because, okay, so let us take it as dl. Okay, because there is nothing wrong to take it as dx, but that will be a misnomer or that will, so that can create confusion. Okay, all the things are same, mind it, but all the things are same, just I have replaced the name dx by dl. Okay, so then this is dl. Okay, then this is dl and this is dz and dx. Okay, now it is fine. So I have this theta, I have this theta with horizontal and this is the theta. So dz equal to dl sine theta, right? Dx equal to dl sine theta, that is dz. Okay, then dl equal to dz by sine theta. So then just replace it here, this patm plus rho gz. So this will be dz by sine theta into b. Okay, fine. So if that is okay, now so now we have to integrate this. So patm into b by sine theta into z, and the limit is from, okay, so the limit is from, the z limit is actually from this height to, okay, so I have to calculate the forces on the rod only. Okay, so the z limit is from which color I can use is, okay, so let us use this color of wood. So this height only and up to this height, right? So let us call it as zb and za, depth of b and depth of a. Okay, so this is from zb to za, fine. So now let us proceed. So so this will be za minus zb, okay, plus rho g, okay, by sine theta. Okay, and let us put it as, the this integral form. I will show that why I have put it in the integral form only, and that is za to zb. Okay, okay, so we have calculated the pressure force P, okay, on the plate. So now just very carefully look at these two terms. So this first term, okay, this first term, which is P ATM into B into ZA minus ZB by sine theta. Okay. So what is ZA minus ZB? So ZA is this. Okay. So just let me draw the diagram of the plate and nothing else. So this is the plate. Okay. And just this was the free surface only. So this was the free surface and this is ZA. Okay. This is what? ZA, right? ZB. Okay. So this is the end B, or then this is ZB, and ZA is nothing but this. This is ZA. Then this height. Then this height is. Then this height is nothing but this height. That is, if I draw this one, this height is nothing but ZA minus ZB. Okay, and this is theta. So, and this is, I know that this length is L. So that is L sine theta is equal to ZA minus ZB. Then ZA minus ZB, ZA minus ZB by sine theta is equal to nothing but L. So this directly becomes B into L. So that directly becomes P ATM into area of the plate, into area of the plate. Okay. Now let us come to this thing, this term. So if now I come to this term only. Okay. So now I come to this term. So this is rho g b by sine theta into, now this is z dz. Okay, za to zb. So fine. And if I take this b into the integral, so then it is, and this sine theta also in the integral, so then it becomes this. Okay, z by sine theta is nothing but, z by sine theta is, okay, z. So this is z. Okay, so dz by sine theta is dl. Okay. Okay, so now that becomes dz by sine theta is dl, so b dl. Okay, b dl into z. Okay, so b dl into z. So that is fine. Okay, now in the z coordinate, in this coordinate, let us say z coordinate means directly this coordinate, right? Z coordinate means this coordinate only. Okay, so in this coordinate, if I have to measure this z of centroid, of the plate, then what is the formula? The formula is nothing but dA into z by summation of dA. Okay, dA into z by summation of dA, right? So this concept is there in calculation of the center of mass of a plate. What I am trying to say is, uh, this is the z coordinate, and I have to find. So this is the z coordinate, coordinate of the surface, surface centroid. Okay, surface centroid or the area centroid, and the corresponding formula is this. So that directly means that integral of dA z or zdA is directly z of c into integral of dA. Okay, and this and this quantity here, this quantity here is nothing but z into dA, because dA is nothing but b into dl. Here dA is nothing but this b into dl, right? So and this z into dA, we can write this into integral dA, and that directly is zc into area. Okay, so this total equation, this total expression becomes, okay, this becomes rho g into what, zc into area. Okay, now I have this plus this, so fp equals to p atm plus rho g zc into area. Okay, so this is the formula for any surface. I have taken a surface that is rectangular in shape, but this is valid for any surface because I did not have integrate this formula by z square by 2. If you just directly integrate this formula to get z square by 2, then also, and if you find this, and uh, if you just put this value of zc here, then also that will give the same result, same answer. Okay, okay, so if that is fine, now, so this is now okay. So this thing is the actual pressure. So pressure at point C, and this is absolute pressure at point C. C means centroid, point centroid of the, on the plate, on the plate or the surface area. Fine. Now this term, look very carefully, this term is nothing but absolute pressure P absolute at C minus P atm. Okay, so that is the gauge pressure P gauge at C centroid. Okay, so that means Fp is nothing but P gauge, okay, plus P atm into area. Okay, P gauge at C. So just remember this very important formula, and this is the ultimate formula for deriving the force on a flat plate or on a plane surface submerged in the liquid. Okay, so this is the ultimate formula. In your semester examination, you can be asked to prove this, then you have to prove this by these all these steps. Okay, by all these steps. Okay, fine. So for this flat plate, let us just assume that this zb is given. Okay, zb is given. So then from this diagram, the zc is nothing but zb plus this distance, uh, this distance zb plus this, because the as it is a rectangular plate, the centroid is at the geometric center of this surface, and that is at the mid length. So this length is nothing but L by 2 sine theta. So this is Z, okay. So this is L by 2 sine theta. Clear? So this is ZC. Just put this value up here, that is ZC equal to ZB plus L by 2 sine theta. Just put this value here and to get P ATM plus rho G ZB plus L by 2 sine theta into B into L. So this will be the pressure force on the plate. Okay, this will be the pressure force on the plate. Okay, likewise we can find any pressure force. Okay, okay, okay. So now let us proceed towards a very important topic of fluid statics, and that is nothing but the concept of center of center of pressure. Okay, sorry. So okay, so now I will study center of pressure. So first of all, let us try to understand that what the center of pressure is. Okay, so let us consider the same plate. So now this is the free surface level of water, and this is the plate. Okay, so at this point, so let us say at this point, this was our B and this was our A, right? This was our A and B. Yeah, okay. So if I ask you that PB is what? PB is P ATM plus this rho G ZB. ZB is depth of the point B. PA is what? P ATM plus rho G ZA. This we have learned. So if I have to draw the pressure, the direction of pressure force on these points, then this will be the directions, right? So on B this is like something like this, and now let me assume that the length of this arrow is denoting the magnitude of this pressure force. So the arrow in point A should be greater than the arrow in point B, because in point A the magnitude of pressure is more, because ZA is more than ZB. So again, if I have to do this, that is, so this arrow is depicting the pressure force on A. Now the equation of pressure, that is P at any height Z, is related as P ATM plus rho GZ. So that is a linear relationship. That is a linear relationship. So that means the variation of pressure from point P to point A is linear. So let me join these two tips of arrow. Okay. So now if I draw the arrows like this at every point of the plate, so then these arrows will show the direction and magnitude of pressure force at different points of the plate. So this is the pressure variation, okay, along just any line. Okay, and we all know at this plate, as this plate is a two-dimensional figure, considering the thickness to be negligible. So, and now if we just for the concept, that is, this diagram is not actually, so this is our pressure, okay, pressure variation diagram, right? Pressure variation diagram. So don't think that this diagram is 2D. This diagram is actually a 3D concept. Why? So just expand this plate, just expand this plate, or not expand, sorry, just project this plate like this to get the actual cross section of the plate. Okay. So now if the actual cross section is, I have considered to be rectangular, but I have shown you that we can calculate the pressure force for any cross section. So let us assume an arbitrary cross section here, and that is something this, an arbitrary cross section. Okay. So if we view from this side, okay, so then this will be the arbitrary cross section. The fact is that, so at this depth, so let us consider any arbitrary depth. So at this depth, okay, or at this point, if I project this point on this surface, okay, then throughout the cross section at this level, so if I draw a line, okay, if I draw a line on this, okay, if I draw a line on this at this level, so all the points, this point, this point, this point, this point, all the points are at same level. So that means that at all the points at this level, or at all the points at on this line, the pressure is same, and that is equals to, P equals to P ATM plus rho g z, where z is this arbitrary height. Okay, fine. That means, so this trapezium is just the cross section of the whole pressure something, uh, what should I call? So let me draw, let me just try to draw the actual pressure variation diagram in 3D. So on this cross section, the pressure variation diagram would be something like this, that on any line like this, there will be a rectangle. Okay, so that rectangle will be something like this. Just try to imagine. I am drawing this effort because uh, to make understand all those guys who are studying fluid mechanics for the first time. If you have studied fluid mechanics or this type of thing, then you will be able to understand. So this will be the, okay, okay, so this will be the, sorry, this rectangle, okay, this rectangle, all these arrows are having the same length, okay, and these are also arrows. So this length, okay, this length is nothing but the magnitude of pressure. And if I draw another line, at this point, at point B, actually at point A, sorry, at this, end, okay, and let me draw another line at this extremum. Okay, so both this extremum will have a similar kind of rectangle, okay, but this side of the rectangle is greater at point A. As we know, the the pressure at point A is more. Obviously, as this part has no mass, so the diagram will not extend till there actually. So let me just remove it. The diagram will be extended to this part only. Okay, this one and this one. Okay, and let me join these two to form a rectangle. Okay, so okay, therefore this arrow, this arrow, all these arrows are having the same length, and the magnitude is PATM plus rho GZA. Fine. And now at this position, so this this line is corresponding to point A, this line is corresponding to point B. At this position also, if I have to draw a similar rectangle, so now I will have a comparatively smaller, a comparatively smaller sized rectangle. Okay, so this is the minimum shape, so this is the minimum length that I can draw. So let me draw it by hand only. Okay, so this is the length, and here this is the length. Okay, and let me join this, sorry, so let me join this by two lines, by this line to form a rectangle. And in similar way, if I draw arrows, if I draw arrows, so these arrows will have the magnitude as PATM plus rho G Z of B. Clear? And now if I join all this, okay, so this will be this is not looking like a linear variation. I have to join, I have to join this point, and this point, and ideally uh, they should be joined by a straight line because the variation is linear. Okay, so ideally, if I, so what can I do is, so let me just join like this, but and it's like this, so this point and this point. Okay, so this is the volume. Okay, so this is the volume, this is the total, this is the total volume. Okay, but just mind that this line should be a straight line, should be a straight line, straight line. Okay, so this is the actual pressure force variation. Now if I want to replace this force variation by a single force. Okay, so I have the same surface by now, but now I want to replace this, all this pressure variation by a single force, and let me say that the force is acting through this point. Okay, so as the pressure always acts the perpendicular, sorry, again I am making the same mistake. So okay, so let me consider that the pressure force is acting to the same, so same thing, and the magnitude of this force is nothing but Fp, and Fp is the total volume of the pressure distribution. Distribution. Okay, and that is nothing but this Fp for that parallel plate, or this formula same. Okay, but now my point is that my focus is on this point, on this point. So that is called the center of pressure. Okay, so if I project this point, so then maybe it will lie something here. Okay, maybe it will lie something here. So this point, this point is called CP, or center of pressure. So I hope that the concept of center of pressure has been clear to you. If not, just let me know in the comment box. Okay, so if I have to give some definition of center of pressure, so I will just make my own definition because I have understood the thing. Just make this kind of mindsets. Okay, the definition has to be just scientific. Okay, you don't have to mug up. So center of pressure is an imaginary point through which the total pressure force can be thought to be acting. Clear? Okay, so again, if I draw the force through this point, then this is my FP total, total pressure force, right? So first of all, my objective is to find the position, the position of CP. Okay, to find the position of CP, that is, I may be interested to find this height. So let me call it as ZCP. I may be interested to find this length, that is the distance of CP from A. It has, so let me call it LCP. So just see that you can find this LCP from your common Euclidean geometrical knowledge. How? You know this length, of this trapezium, and this has the magnitude this, and you also know this length is having the magnitude this one, and you know this length as L. All these are given, so the important dimensions of this trapezium are given. That's why, so now this center of pressure geometrically is nothing but the geometrical center of pressure, distribution, right? And this pressure distribution is symmetric along this axis, that is perpendicular to my tab, perpendicular to your board on which you are learning. So along this line, actually along this line, okay, the along this line the pressure variation is symmetric. So just by considering this 2D variation, I have to find the geometrical center of this 2D variation. So LCP can be found by geometrical uh, center of the 2D pressure variation, right? So for example, if this was a triangle, so then of the same base length actually, so then LCP should be 1 by 3 of L. So this was the direct answer, right? And once you can find this LCP, you can easily find the Z, provided that the angle of inclination of the plate with the horizontal or vertical is given, right? All this by geometry. But From the fluid mechanics consideration also, there is a formula of finding the center of pressure, because in gate, so if the pressure variation uh, uh, is like a trapezium like this, so then either you have to memorize the formula of center of mass, a formula of centroid of a uh, trapezium, the position of the centroid, or you have to memorize this. So that's totally up to you, but this is taught in fluid mechanics, that by the concept of mechanics you can find the center of pressure, and that is what I am going to do here. Okay, so now let us consider this plate again. Let us consider this plate again. Okay, sorry. So this is the free surface, and this is the plate, and this is the plate. Clear? So again, now let me assign some axis. Okay, so this axis pointing towards this. Okay, sorry, pointing towards this direction is I name as y. Okay, and this axis I can name as z. So that means the axis perpendicular to the plane of the tab or plane of the board, this is nothing but x. Fine. So now let me consider again that infinitesimally small volume, and that is here. So infinitesimally small area will be here. Dx is equals to some the width. Okay, sorry. So this I mean this this length is actually dx. This length is dx. This small length, I am sorry, and dA is equals to b dx. I have shown all these things in the previous calculation of the pressure force. So the same thing is here. So that means the infinitesimally small pressure force is nothing but the pressure acting in this point into this dA, and the pressure acting is the in this point is P atm plus rho gz rho g. So now let me not call it z, just let me call it some h. Okay, some h. uh, so this is h. Okay, because z is this coordinate, so I have this rho g h clear into dA. Fine, that is, so I can write this dA as b dx. Okay, so also this is not dx actually. So in this direction I have the y, so let me directly replace this x by y. Okay, let me directly replace this x by y, that is this is dy, and this is also dy, so this is also dy. Okay, just to avoid the confusion, nothing else. Okay, so fine. Now if I have to calculate the moment of this infinitesimally small force, moment of FdP about the x-axis, and that we write by this one. So x-axis means if I again draw a projection. Okay, if I again draw a projection, right, if I again draw a projection, and if I am having this type of a cross section, any cross section, so this axis, the axis in the z is having the orientation like this, like this. So this is my x axis. Fine, I hope the orientation of the x axis is cleared. I am just removing this. Okay, sorry. Okay, let me draw this arrow again. I'm sorry for all these things, just a bit little inconvenience. Okay, so let me draw this arrow. Okay, I'm sorry for that. Okay, so now the moment due to that infinitesimally small force, and that I call an infinitesimally small moment due to the pressure force about the x axis. So that will be this force multiplied the momentum, and the momentum here is this one. So that we consider some particular y, that we consider some particular y, right? So this will be something PATM rho g, this one, into, so by dy, correct? Okay, so this should be the plus one, right? Okay, so now I can replace this h. So now I am given if I am given this angle, okay, if I am uh, given this angle, this is the horizontal line but not looks like, right? Okay, so now if I given this angle as alpha with the horizontal, then this y sine alpha is h. Okay, this y sine alpha is equals to h. That means I can replace the, let me say I can replace the h, okay, by y sine alpha. Okay, so that is fine. Or let me replace this y by h by sine alpha, and that means this dy is dh by sine alpha. So if I replace this formula into this one, then I can write it as PATM plus rho gh b into h dh by sine square alpha. One sine alpha due to y, another sine alpha due to dy, right? So now this becomes PATM into BH dH by sine square alpha plus rho g h dh, and there will be an h square, actually h square d, and there will be a b. Okay, there will be a b and by sine square alpha. Okay, fine. So that is totally okay, clear. So now the total moment, okay, if I have to calculate the total moment, okay, the total moment will be due to pressure force about xx is equal to this integral of this one, right? Okay, so this will be the integral of this one, right? So if I integrate, so this PATM is constant, this sine square alpha is constant, so this becomes this h BDH, right? Plus rho g is constant, okay, rho g is constant, and this h square, rho g is constant, and so by sine square alpha is also constant, so this becomes this h square b dh. Clear? Okay. Now if that is clear, so what is this b dh? So dh means dy sine alpha. Okay, so now let me replace that. Okay, so dh means dy sine alpha. Okay, so that means that, and h means h, and h also directly means y sine alpha, right? So if I take only this term, okay, just understand the mathematics very carefully, because you may have to derive this in your exams. So h means y sine alpha. Okay, so there will be a sine square alpha out, there will be a y square, there will be another sine alpha, because dh means dy sine alpha, right? So another sine alpha, so these and these will be cancelled out, and this is b dy. Now this is now b dy, but this b dy is nothing but the dA, so this is y squared dA. Okay, so now just tell me that what is this term? This term is what? That is summation of y squared dA. So if I have to calculate the I, okay, or yes, if I have to calculate this I, okay, I about xx, okay, if I have to calculate this I about xx, right? So then that is equal to this uh, this y square dA, right? This y square dA, and this is nothing but the second moment of inertia, second moment of area, not inertia. So this is the second moment of area, right? So how can we uh, so this is nothing but the moment of inertia about the x axis. Okay, so just let this be like this. Okay, so now if I consider the center of pressure at this point, okay, so let me say that the height of center of pressure is this, and this is hcp, so this is the cp, and the length for which we are interested, so now let me call this as this ycp, and this is this distance, so this is called ycp. So center of pressure is the point through which the total force is assumed to be acting, is assumed to be acting, right? Therefore I can write this mp, moment of pressure force, as my actual pressure force, actual pressure force into this ycp, because this pressure force can be thought to be acting through the center of pressure. Now if I equate this and this equation, and what do I mean by the actual pressure force? What do I mean by the actual pressure force? That is the integral of the dfp, and that I saw that this dfp should be this pressure into dA, and this pressure was this patm, this patm, right, plus rho g H at any point into what? This dA is BdL. This I saw. Okay. Okay. So if now I can equate this and all this. Okay. So this is FP, right? This is FP. Now if I have to equate these two. Okay. So PATM into BDL into BDL. Okay. Into BDL into some YCP into some YCP plus rho GH. And now what do I mean by H? H means here, so L I have taken is, so this was my actually DL and I have taken this as DY. So these are the small mistakes that we made because of the lack of the concentration. So there should be this DY actually. Okay. So this will be also DY. So will be this DY. So rho G. Okay. And H means Y sine alpha, right? So just replace this as Y sine alpha. Okay. So then it becomes rho G sine alpha into by d, so into y into b dy, right? Into y into b dy. Fine. And I have to integrate all these things, right? Okay. Integration into ycp actually. So this whole into ycp. Okay. And this whole into ycp. Okay. This whole into ycp, right? So now this is equal to this plus this. Okay. PATM plus sine square alpha. PATM plus sine square alpha. Okay. Now this HBDH, this can be replaced as sine square alpha into YBDY into YBDY, right? Because H equal to Y sine alpha. So into sine square alpha into YBDY means what? Y into dA, right? Y into dA. So I think I am clear. Okay. Okay. So this is Y into dA, right? And plus this term. So that I have got to be rho g into sine alpha because of all these calculations. Rho g into sine alpha into okay. So let me write it as y squared dA only. Y squared dA along, okay, along the area, which is also along the area. So during the calculation of the pressure force, I told you that this term is nothing but the the center the centroid coordinate into the integral of dA, because the centroid coordinate is equal to y dA by integral of dA. Okay. So this is only the concept of center of mass, and in our case this C is the, so this C is the, okay, also the centroid. So I am writing this C as this Y. Okay. This Y bar. Okay, not C bar. Okay. So now that is fine. Okay, so if that is fine now, so then I can write this equation as p atm into integral of dA into this y bar, fine, into this y bar, plus rho g sin alpha ixx. And now let me write this part very clearly. Okay, so for this part only, I can write this as this p atm is constant, ycp is constant. So again I have this bdy, so that is only the dA part. Okay, so that is only the a, because integral of dA. And if I have to write this part, okay, so that is rho g ycp sin alpha into, that is y into bdy, and bdy is nothing but dA. So that is integral of y dA, right, integral of y dA. And that I have shown to be, nothing but y bar into integral dA, that is a. So this I can write as a actually. Okay, so let me write it as a. So this is a into y bar. So now let me write this total equation, that is p atm into ycp into area plus rho g ycp into sin alpha, okay, into y bar area. Okay, that is equals to p atm a into y bar plus rho g sin alpha plus ixx. Okay, okay, then then if I can take this p atm a common from this term and this term, then I have this ycp minus y. And if I take common rho g sin alpha, okay, common, then I have, okay, then I have something, okay, so then I have something called this into sin alpha common. So then I have this ycp into y bar a, ycp into y bar a minus ixx. So that is equal to 0, right? So that is equal to 0. Okay, so now from this equation only you can find the value of ycp, right? So if now I directly consider, that is uh, due to this p atm a, so p atm is constant actually. Okay, so p atm is constant, so let me directly take this ycp common. Okay, so this will be a more important or other helpful step. Okay, into y bar a, okay, into y bar a, and that is equal to p atm into a into y bar, okay, plus rho g sin alpha ixx. Okay, that means this ycp is equals to p atm a y bar plus this rho g sin alpha, okay, ixx by PATM A, okay, this PATM A plus rho G sin alpha into y bar A, okay. Now in general situation we only work with the gauge pressure, okay, we only work with the gauge pressure, okay. So if we work with the gauge pressure, if we work with the gauge pressure, then also this Cp will be same, this yCp will be same. So this is the actual expression. Just forget this line, this line is of no use, okay. So this is the actual expression of the yCp, okay. So now if for simplicity, considering gauge pressure, gauge pressure. So I have told you that the concept of gauge pressure is nothing but the concept of gauge pressure is nothing but that is P gauge equals to P minus P ATM. So in gauge pressure coordinate, P ATM, that is atmospheric gauge pressure, is nothing but P ATM minus P ATM, and that is nothing but 0. It is nothing but 0. Okay. So in that case, this term vanishes, this term vanishes, and the yCp directly boils down to, so then these all terms will be cancelled out, Ixx by a y bar, okay, Ixx by a y bar, so this is the formula of yCp, okay. And now, so if now I, so this is the formula that you have to remember, because yCp, the value of yCp is always remaining same, okay, whether you consider the gauge pressure or the actual pressure, okay. So now if I do this, so Ixx, now Ixx is equal to X bar plus a into y bar square, a into y bar square, am I right? So this is the parallel axis theorem. So this x bar is centroidal axis. I am not going to the details of this formula because this you are supposed to do in engineering mechanics, because I can go. So if you feel just a bit uncomfortable with this formula, you just let me know in the comments. So then I will go in details. Okay. So this will become Ixx plus a y bar square by ay, okay, and that is nothing but Ixx bar by ay plus, that is y bar. So for a general uh, general cross section, this is easier to, remember. So that's why this formula is taken whenever you consider to find the yCp. So this is the actual formula, okay. Okay, and now uh, okay, so Ixx, so this we have found out, okay. So this is the actual formula, and now once you find this yCp, then you can find the hCp also, okay, just by doing this yCp sin alpha, right? Okay, so this was the actual formula, okay, this was the actual formula. So I think all the things are clear up to this. Okay, all the things are clear up to this. Okay, so just let me know if you have any, if you have any confusion. So in the, so let me give you a, a suggestion, that is, if in exam you are to derive this thing, just at the beginning, just write that I am considering the PATM to be zero, and that is the gauge pressure concept. Okay, I am considering the only effect of the hydrostatic force, and you can say that and you can directly uh, come down to this one. Okay, so just remember that during your examination, just say that I am considering the gauge pressure. And also there is a very good conception, that is, this pressure variation is just because of only the hydrostatic variation. So if I draw a line here, all these are concepts that that should be in your mind. Okay, so okay, so this length, okay, so this variation, this triangular variation is there just because of the hydrostatic case. Okay, because the the length of the, I mean the effect of the pressure because of the atmospheric pressure is same all through the points, all through the points. So at any point P is equals to P ATM plus some rho gz. So this is like an intercept. So if I draw P versus Z, this will be like something this. Okay, so this part is PATM, and that is constant for all the cases. Okay, this part is PATM and that is constant for all the cases. And the center of pressure, if if only PATM was acting, should be on the, should be on the mid position of the plate along the length. Okay, so in that case actually, if I consider the effect of PATM separately, so then, so then this YCP must turn down to y by 2. Okay, y by 2, this YCP must turn down to y by 2. Okay, okay, so now, sorry, okay, so now let us go down to this expression again, and I am solving this one for you. That is, if I put this one here, okay, and also h bar is equals to y bar sine alpha, then directly YCP means HCP by sine alpha, okay, is equal to this bar sine alpha by AH bar plus H bar by sine alpha. So that means that HCP is equals to I x bar sine square alpha by AH bar by plus H bar. So this formula is also very important. So this formula directly gives us the height. So for gate, I will suggest you to remember only this formula, or actually this formula. By, I mean, uh, my suggestion is always that ki, I mean, just try to remember as least as possible. Okay, so just you can remember either this one or this one. Okay, so in examinations you are required to find this length actually. Okay, this LCP or HCP or LCP or YCP, and I will show you some of the example problems. I will conduct some series on particularly the problems. Okay, and in the meantime you can go through the past few years, okay, in which you are asked to calculate some moments of the of the pressure force. And for calculating the moments, you need this YCP or HCP. Okay, so this was a very important part. And let us just quickly complete another part, that is, if now I take a moment, so I took that moment of pressure force about xx. Now let me take that about yy. Okay, about yy, and the yy axis is this. Okay, that is along the length of the plate. Okay, so if I take that, so then it will be something. Let us say that distance, that distance I call xcp, not ycp, into pressure force, that is xcp into, again, the I am now neglecting the PATM term. Okay, now that is rho gh at any point, neglecting the PATM term, into dA, that is BDL. Fine. And why I am writing that xcp? Because now if I again project, so then after projecting, so if I again project, okay, I am just drawing, if I again project, I will remove all those things. So then this will be some cross section, and this is my x coordinate, this is my x coordinate. So this is my x coordinate. Okay, so and let me say that my what and let me say that my y coordinate is this. Okay, so then this is the origin. So now if I have considered an elemental area like this, right, like this, so the force must act through the through this point actually. Okay, so this point is xcp, and because this direction I have shown x, this direction, that is why I have taken it as xcp. Okay, I am just removing these things. Okay, okay, and that will be directly equal to the same if I follow the same formulation, that is, if I calculate it by this concept, that is differential moment, and the differential moment will be equals to differential force into the moment arm, that is x, and the differential force is again equal to rho gh, okay, rho gh into the dA into x, and that dA was this. I am doing it a bit faster, but if, because I I want that you do all these things by yourself. Just consider the gauge pressure. Okay, because of the simplicity. Okay, so these two things are again equal, right? Then I am directly writing this rho gh dA is equal to this rho gh b dy x. Rho g are cancelled out. So then directly I am getting that that this uh, also I have h equal to y sine alpha. This I have. Okay. So let me convert the h term into the y terms. So this will be by dy x by sine alpha by, again, this will be uh, y dA or y dA by sine alpha. So this sine alpha and sine alpha are getting cancelled out, and now this b dy, b into dy is dA. So this is dA into xy, and this is coming as our y dA. So again I know that my y direct means a into y bar. I have I have spoken about this concept multiple times. Okay, and this thing is known as the product moment of inertia Ixy. So this is coming as this. Okay, then xcp is coming as this, is equal to Ixy by ay. Okay, so this is also a very important, and the more important thing is, if I take so let us say that I am drawing here only. So this is my cross section. So if I take, so this was my x-axis, let us say this was my x-axis, and this is my y-axis. Okay, so this is my y-axis, y. Okay, so if yy if yy is a centroidal axis, or if yy is an axis of symmetry. Okay, then I have this much area A, let us say here, and also this much area A, let us say here. So these are symmetric. So if I calculate, so let us take me an elemental mass here and here. So the x are same, the the y is same, and this is the y, and it is same for this, but this is x and this is minus x. So this Ixy will be this dA into xy. So for this one it will be dA into xy, and for this one this will be dA into minus xy, because of this minus x, and that will be cancelled out. So that's why if I take this y as my centroidal axis, then this Ixy is actually 0, is Ixy this Ixy is actually 0. So this is actually not very important, because in any of the, generally in any of the maths you are not asked to find this xcp, because generally we can take the coordinate axis from our choice, from our reference view. So we always take this x y z should in our centroidal axis, as our centroidal axis, such that this xcp lies on this line only, then I have to find only this coordinate, and that is nothing our ycp, and as the point lies on y axis, this xcp is 0. So this was also a very important concept. And lastly, just see that how quickly I have derived this xcp, and that much quickly I can derive this HCP if I forget this formula, unfortunately. Okay, so my point is that just derive every formula by yourself, so that uh, even if you forget the formula in the examination hall, you can derive by yourself just in few seconds. I can derive this formula under 20 seconds or under 15 seconds. Okay, just be like that. So then you don't have to remember a lot of things. Okay, so again, just uh, just share these videos to those who need this, and if you want, you can subscribe. That actually works for me as my motivation, but that's not much a factor. Even if at least if any one person is also getting benefit from these videos, then also I am very happy, and I am willing to do all these things. Okay, so just share in the comments if you have any suggestion or any doubt. Thank you, and just take care, and let us meet in the next discussion.